My name is Alex Cambio, period A, Mr. S. Jardins, and my supercarbon is on alcohol. In chemistry, an alcohol is an organic compound in which the hydroxyl functional group, negative OH, is bound to a carbon atom. In particular, this carbon center should be saturated, having single bonds to 3 other atoms. The first alcohol, today known as ethyl alcohol, was discovered in the 10th century by Persian alchemist al-Razi. The current Arabic name for alcohol means spirit or demon. It was originally used for very fine powder production. Alcohol is commercially produced using a process called fermentation. Fermentation is a process in which yeast breaks down sugar into alcohol and carbon dioxide. Yeast are tiny single-celled fungi that contain special enzymes responsible for this reaction. The formula is glucose plus yeast yields alcohol plus carbon dioxide. Carbon dioxide gas bubbles out of the fermenting solution into the air, leaving a mixture of ethanol and water. It's important that no air is present or the yeast will produce ethanoic acid, the chemical found in vinegar. Many other alcohols can be made this way, but are more likely to be produced by synthetic routes like natural gas, oil, or coal. Some physical and chemical properties for alcohol include that its odor is considered biting, it can form hydrogen bonds, it can react to form compounds, it can undergo oxidation, and it is usually a liquid. It is also a polar molecule, and its boiling point is 78.29 degrees Celsius. Shown on your screen are the nomenclature rules for naming alcohols. Step 1. Name the parent compound. Find the longest chain that has the hydroxyl substituent attached. Step 2. Number the carbon atoms in the main chain. Begin at the end nearer the hydroxyl group, ignoring the location of the other substituents. Step 3. Write the name, placing the number that locates the hydroxyl group immediately before the parent compound. Dialcohols, or diols, are often called glycols. 5 examples of alcohol are methanol, ethanol, propanol, butanol, and pentanol. Uses for alcohol include synthetic intermediate, cleanser, cosmetics, fuel, perfume, alcoholic beverages, and it is used to sterilize objects. Shown on your screen is a page from the material safety data sheet for ethyl alcohol. Shown on your screen is a diagram for the compound alcohol. Carbon is considered the king of chemistry. 5 reasons why carbon compounds keep getting discovered each year are: first, because it can exist in 3 different structures. Also, because it has a high ability to form long chains, and it is the 4th most abundant element in the universe. Carbon is also in all living things, and lastly, carbon atoms are really small, so they form strong bonds. Shown on your screen is a picture of my pamphlet that I made for alcohol. I will bring it to you in class the day I hand everything else in. This is the start of my summary booklet. To start off are polymers. Polymers are a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together. Examples are many synthetic organic materials used as plastics and resins. Second is amides. Amides are an organic compound containing the group negative CONH2 related to ammonia by replacing a hydrogen atom by an acyl group. Third are amines. Amines are an organic compound derived from ammonia by replacement of 1 or more hydrogen atoms by organic groups. Third is ether. An ether is an organic compound that contains 2 acyl or aryl groups by an oxygen atom. Next are carboxylic acids. Carboxylic acids are an organic acid containing a carboxyl group. The simplest examples are methanoic acid, and ethanoic acid. Next are ketones. Ketones are an organic compound containing a carbonyl group, CO, bonded to two hydrocarbon groups made by oxidizing secondary alcohols. The simplest such is acetone. Next are aldehydes. Aldehydes are an organic compound containing the group CHO formed by the oxidation of alcohols. Typical aldehydes include methanol and ethanol. Next are esters. Esters are an organic compound made by replacing the hydrogen of an acid by an alkyl or other organic group. Many naturally occurring fats and essential oils are esters of fatty acids. Second to last are alkyl halides. The haloalkanes, also known as the halogenoalkynes or alkyl halides, are a group of chemical compounds derived from alkanes containing one or more halogens. They are a subset of the general class of halocarbons, although the distinction is not often made. Last but not least is alcohol. In chemistry, an alcohol is an organic compound in which the hydroxyl functional group -OH is bound to a carbon atom. In particular, this carbon center should be saturated, having single bonds to 3 other atoms. And lastly, shown on your screen is my 3D model of alcohol, C2H6O. And that is it for my supercarbon. Thank you for watching.